The problem statement is rotate image. So they are given n cross n 2D matrix. So and we have to rotate that matrix by 90 degree clockwise. And constraints are like n could be 1 to 2, so it will maximum 20 cross 20 matrix, or value of is minus 1000 to 1000. So it doesn't matter for us what is the value of the matrix is for right now. And what is the matrix length? N equals to matrix lengths are like it is n cross n matrix as they say. So this is a constant. So another question is given here, like we have to rotate the matrix in place, like which means like we have to modify the 2D matrix. We have to modify the matrix instead of creating. We can't allocate another 2D matrix or can't rotate. Then rotate. Sorry, my bad. Like we can't create another matrix and then rotation. We can't do that. So first see the problem statement. Let's don't look into this constant. Okay. The thing is, this is an approach. Okay. So how we could solve the problem? They can't see. They will at the end. They will only see like how we just what is the answer, what is the final outcome, and is it matching with this expected outcome or not. So this is the thing. So we will come this thing at the end. Before that, we will just simply try to solve the problem. How could we solve the problem? Okay. So now coming to this problem, what is the problem is? So what we can see, rotation means like 90 degree rotation, like 5 becomes here, then 1 will become here, then 9 will become here, then 11 will come here. Correct? This is the how they do the rotation. Okay. So as I said, I am naming this thing as a grid. This is my new grid, and this is my new grid. So I'm doing the exact opposite here for they're saying like I'm creating a new 2D matrix and I'm solving. Afterwards, we will see like how to solve without creating the matrix. This will be later. Like we have to think first, like how could we approach? How could we solve? If you just say like for the day one, I will solve DP or the hard problem, it's not possible, right? So this is also if it is a medium level question, this is an easy one. Using the grid, it will be easy one. Without using the grid, it becomes the medium. So first, see about the easy one, then we'll move to the medium. Like this is how you should proceed. Don't directly jump to the final conclusion. Okay. So let's see what else the rotation means. Let's given try. So 5 will become say 90 degree rotation. So if I rotate 90, so this image will rotate 90 degrees. So how it looks like. So 5 will become here. So 5 will becomes 11. Then 1 will come here. 1 will come here. Then 9 after rotation it will come at this place 9. Then 11 it will come at this place 11. This is the rotation works. So this is the first row. Next it becomes like 2 will come at this position 2. Then 4 will come at this position 4. Then 8 will come at this position 8. Then 10 will come on this position 10. Similarly, after same for others, like let me fill this thing. So 13 will come in this place, 3 will come in this place, 6 will come here, 7 will come. And at the end, until 15 will come here, 14, 12, and 16. So see, so there should be a pattern. Like it cannot be randomly comes. It should be a pattern. Like assume as I shown earlier, like this is my actual given grade, and this is my output. Okay, so there should be a one mapping, one formula or something. You say some relation between this cell and this cell, this cell and this cell, or we can say from this column to this column. There should be some relation, right? Let's see and let's map it. Let's see could we get or student. Like we said, so it's a grid. As I said, it's a grid. Okay, so it's a grid, and it becomes my new grid. New grid. So let's see what is the index position of the 5 starting. It is obvious, pretty obvious. Time comes to the n square because the thing at the end I have to just change this thing, change this. All right, like I have to iterate to each and every element. Then I have to do for this, go for changing, right? So I have to iterate for each and every element for now. So that see the index for the very first element 5 5. What is the index value of that? 0 0. And what is the like final value of that 5? It will be 0 3. So I am taking this is for 0 0, this is 0 0, this is for this one, and 0, 3, this is for this one. Similarly, let's do for the other element like 1, 9, and 11. So let's do it. 1 is 0, 1, and new grid it becomes 1, 0. Sorry, my bad, it is 1, 3. Now it becomes 0, 2, like ninth element line, 9's position is 0, 2. The final position would be of 9 would be like 2, 3. Fine. Then let's see like what is the last 11th position. 11th position is what is it? Is 0, 3. 0, 3, and it becomes 3, 3. Okay. Let's see for another row, another set. Let's see is there any pattern or not. So 2, 4 is what? It is 1, 0, and it becomes 0. Sorry, not 0. It is become 0, 2. Right, correct. I am correct. It's 0, 2. Then it becomes 1, 1. It becomes 1, 2. It becomes 1. Then sorry, the value of the position of 8 is 1, 2. The final position of 8 will be 2, 2. Similarly, position of 10 is 1, 3, and final position would be what? Would be 3, 2. So can I see any pattern? Check it carefully. See this one. So 0 for, let's see, I, what will I and j? I is 0, j is 0. Sorry, I of the current grid is 0, and it is the I new and j new. Okay. So what will be the thing? Like 0, this is also 0. This is 0, this is 1. Okay. So I am finding a pattern: 0, 1, 1 increase, 0 to 2 increase, 0, 0, 3 increase. Any pattern? Right now, 1, 2, 3, I can see. There also, if you see 1, it is 0, 1, it is 1, 1, it is 2, it is 1, it is 3. So any pattern you can know in this? No. But if you see here, there is a pattern: 0, 1, 2, 3, 0, 1, 2, 3. Now if you pattern, like if you can see, like it's an if new grid, the first I new will be 0, 1, 2, 3, from 0 to n minus 1. Okay, so I can think that way, or we can think another way. If you notice here, it is 0, 1, 2, 3. So it is 0 and 1, 2, 3, same. Similarly, 0, 1, 2, 3. So my new in the I new I value will be my actually j value. So this one actually becomes my, this I minus n becomes actually my j. It becomes j. Okay, let's see my new j value. What will be my new j value? Can I see anything? It is 0, it is 3. This is 1, this is, so first is this, for every j it is same. For every j it is same. Now, can I find any pattern from this? Like 0, 0, 0, 0, and this thing. So there could be a pattern. Like here, see, here all the I value are same. Here all the jth value, new jth value will be the same. Similarly, here all the i's value are same. Here all the j's values are same. So there should be a pattern. So is there any pattern? Okay. So it is an n cross n matrix. Okay, n cross n matrix. What is the value of n? It is 4. Okay. So is there any pattern like 3 and 0 and with this 0, 3, and my n, the n value, it is my j value, it is my I value, j new value, it is I value, this is the value of n. Is there any pattern? Or let's focus on it first. Okay, let's see. Can I see any pattern? So the thing is, first my I value, then j new value, then n value. So I value is what? I value is 0. J values, I am talking about this set, this first set. 0, this is j new value is 3, then it is n. Then it is 1, then 2, then it is also 4. So is there any pattern? If you look carefully, like 0 plus 3 plus 1 equals to 4. 1 plus 2 plus 1 equals to 4. Same thing. So if I need what? I need Jn, right? So what will be the value of Jn? Jn will be Jn will be n. I put this one here backside, n minus I. Then 1 I have to also subtract. So minus 1. So Jn value will be n minus 1 minus I minus 1. So it will be n minus I minus 1. So let's start the pseudocode. The pseudocode will be like this. Like see, I am creating what? This is my new grid, right? This is my new grid. So I need to create a grid with respect to I need to create one grid. Okay. So new grid I did it. So I write a pseudocode. I will not write the code as usual. So you can develop your own code, like it's of any language, anything. You can create your own code. So I guess everyone knows the term like array, vector, everything from their own thing. So if anyone doesn't know, like vector equals to array, like in C++ it is vector, it is array. In Python it is a call as list. Okay. So I have to create a new grid. So my first step will be create a new grid. This is my first step. Create new grid. Then one it will new grid of what? Of n cross n. You can create a blank grid or something or negative value, but it doesn't matter. So it will be n cross n. Every value will be anything with 0, 1 or something. Okay. So next what I have to do? I am doing what? I am iterating through each element from iterative from this to this to this. So this is I am iterating, right? So in that iterate, I have to create a iterating loop, right? Simply. So for my I equals to my 0, for I less than n and I plus plus, I'm iterating, and I have to iterate what? I have to again iterate through my, sorry, right now I'm iterating here, like each and every row I'm iterating. Now I have to iterate every column. So that also I have to also do. So this thing, so for my another index j equals to 0, j less than n, and j plus plus. This is what I'm doing. Okay. And I am going to assign where? I am going to assign my new grid. So this is my new grid. New grid. New grid of something I have to put, right? Now what I am assigning? I am assigning my actual matrix. This is my actual matrix. And this is the what is the value of this actual, what is the value of the actual matrix of this current position? This is simple matrix, or here I am named as grid actually. So grid of I j. Simple. So what will be my index position? As I said earlier, so I new I value will be the actual by current jth value, or what will be jth value? New jth value will be I minus n minus I minus 1th value. So it becomes this one. It will be j value. It is n minus I minus 1 value. After that, what I have to do? Simply I have to simply put that array. Same thing, like I can't return this new array, right? It will be the same array I have to return. So I have to put it back. So put it back means I have to again iterate through each and every element, copy, paste. I have to again iterate back to each and every element, and after that I have to put it back. So here it will be simple change, nothing will be fancy. Here ij is required, so it will be my grid value, and it will be becomes my I value, j value, and new grid value. Simply I will do it and it will work. So this is my pseudocode. So if you write to code, try to run, uh, create or run, make your code on your language and run it. I'll show you in a Python language the same code, and I will try to learn. I just run it and I will show you. I will also give this code in the GitHub. You can take the code from there, and I will also now after that I will focus on the next partition, like next code how to do it without creating the new grid. So as you can see right now here, this is the Python code. I told you I am not wasting time to writing the code, or I will write the code, or some of them will not understand because it is in Python. I'm not writing in C++ or something, so that's why. So I'm not writing the code. So if you wish, I can write. I will show then also like how to write that thing. But let me explain. The thing is this. This is the length of the matrix I'm calculating. Also, step one, obviously you have to find the value of n. I missed that thing. So let's one step, make it as step zero. Step zero. Find value of n, or assembly. I can write that thing is Simply I can write like here, like step 0 n equals to grid dot length. Whatever the function in respect to your language, use that. I'm using that link. So here is the thing. So let's start one by one. So step 0, find the value of length. I am doing the step 0, find the value of length. Now I am creating the new grid. Okay, so I am making as a temp actually. So it is a temp value. So it's a new grid. Same new grid for this one. For I, it is nothing but creating new grid in Python. You can do in C, in vector using in C++ or in array list. You can do in the Java. So array is both of them. So in two here, like in step 2, I am assigning the value new into the new grid. So here also same thing. Like so for every index I am iterating, for every index I am iterating, I am putting the value of this thing, like new grid of j of I minus I minus 1. Same thing I am doing it here. After that, I am putting the value. I am putting the value back. I am putting the value back like in the matrix, as the original grid you can see. I am putting the value back. Here you don't have to return anything. It is given in the question. If you see in the Python, it's a boiler code will be seems like no, don't return anything. In C++ or Java, it is a void one. So you can't return anything. So that's why I'm not returning anything. That's all. So this is how it is looks like. Now let's focus on the actual problem. Like we can't create the new matrix or new thing. Okay, new matrix or new array or list whatever. We can't create that. We have to do in place without this. For this, you need a simple mathematical thing, the matrix inverse. Sorry, matrix transpose. You need to know what is called matrix transpose. So if my matrix is 1, 2, 3, 4, 5, 6, and 7, 8, 9. Okay. So if this is a matrix, if I have to do the transpose, in that case you have to do 1, 2, 3. Transpose means this will come in same place. It will be a left rotation of 90 degrees simply. So this 2 will come here, this 3 will come in this place, and 4 will come in this place. This is how it works. So it becomes 1, 2, 3. If you don't know transpose, just search my transpose in YouTube video and find like how to do the matrix transpose. Like I'll show you how to do the matrix transpose, but let's learn what is the transpose meaning. Okay, so 1, 2, 3. Then it is 1, 4, 5, 6. Then it will 7, 8, 9. This is how it looks like. Okay, what should be the code for that? Code will be simple. So if it is I is my 0 1 thing, 0 1 2 1 2 0. If it is the code, so what my 0 0, it will hold the value of, like this is also 0 0, so 0 1 2 0 1 2. So my new 0 0, I am writing blue means 0 and yellow means old one. Okay, let also color this. Let's color everything purple. We need to understand whatever the color is. Consider this as purple. So 0 1 2. So 0 0 means new one 0. So 0 0 contains 0 0. Now my again new 0 1, it will contain of what? Let me so it will not understand. So 0 0 of old value, it becomes at the place of 0 0. Okay. 0 0. And this one, like 0 1, this one 2. This 0 1, it comes where? It comes around 3. Yeah, 1 0. Simply then here, like 0 2. 0 2 will come around what? It will come around at 2 0. So you can see simply the array, like indexing is changed. Like what is I and j, it becomes j and I. Okay, just swap these two index. Okay, and it comes that. But the thing is, you can't do like earlier we were doing what for I. We are doing for I for everything. I equals to 0 and j equals to, sorry, I less than n and I plus plus, and we are doing what another one like for j equals to 0, j equals to n, sorry, j less than n, j plus plus, j plus. So we are doing that. Right now we can't do that. If we do, it will be a mistake. Let me show how why. So let I equals to 0 and j equals to 0. And this is my place I want to fill. 0, 1, 2. What is my current I? I is here, j is here, right? 0, 0. So if I 0, 0, I'll put it where? As I said, it will be, if you write this formula, it will be a problem. Like nu of ji, as I said, equals to old of ij. It is a problem. Let me show why. So right now 0, 0, ij is 0, 0. Ji will be 0, 0. 0, 0 is 0. So here it will be 1. Fine. So not a big deal. It becomes 1. Now I will stay same. Now j will increase. J will 1. J becomes 1. So here j comes at this position. J will becomes at this position. So it is what? It will be 2. At this position 2 is present. Okay. So obviously like 2 will come in this position. 2 comes in this position. So 2 will becomes here. Now again j will increase. J becomes 2. J becomes 2, and what is the position of the j? J will right now showing 3, and what is the value? It will be 0, 2, right? I is 0 and j is 2, so new value will be 2, 0. So 2, 0. So this it is fine. So you seems like, yo, it's a fine thing. Then why should we worry about it? All right. So actually, it is not a problem. You will understand like right now, then it will be 1, 2, 3. Then it is 4, 5, 6. Like then it will come like okay. So 3 it will be here. So j will it again becomes 0 again. So I will now increase to 1. So it is 1, 4. 4 will stay here. Okay. And then it will become 5. J will become 1, then 5, then 6, then 7, 8, and 9. So it is actually not a problem. It is actually okay. It will work. The problem arise in the sense like see here we can when we're swiping this thing when we are like 0, 1 when I am placed at the 0, 1 it means I'm placing this place 0, 1 I can swap actually, right? I shouldn't just directly put it and directly I can directly swap. So if I'm creating new matrix, it's fine. If I'm doing the old matrix, it's a problem. Like transpose, you don't need. If you're doing any, you're taking extra matrix. Like when I was writing this problem, and make this thing as 0, right? Everything is blank. That means it is a new matrix. What if it is not a new matrix? If it is the actual, the old one, then it is a problem. Like our task is now right now optimize the problem, not actually create every time. So this is the where it comes like 1, 2, 3. It is the original. Now if you iterate from the beginning, 0, 0. So 1 is 1. So 1 will be 1. So there is no problem. 1 is stays 1. So 0, 0 means here. And let me put the j back. So here it is the so here it is not a problem. Like it is one, so one replace with one, so not a big deal. Now two. Now when I comes to here, like j is increased by one, j is increased by one, and it comes in this problem. Like if I move this j here to here, now two, like it is 0, 2. Like sorry 0, 1. 0, 1 means 0, 1 it will becomes 1, 0. New position will be 1, 0, right? New position will be 1, 0. So 1, 0 is a problem. If I directly do assign this value 1, 0, so then what will be the value? Value will be this one. So 4 will be removed and 2 takes the place. Now see the problem. We lost the 4 from our array. Right? We lost the 4. So we can't lose any data from our array or list or matrix. So what I have to do? I have to just swap this value. Like I can swap like instead of just placing I can swap like what is the new j will be there and what will be old j will be there. I can swap that thing. You can say I swap the value. So instead of writing new old, just say swap. Swapping what? The same place swap old one comma old of ji. So if I swap, then it's not a problem because 2 becomes 4 and 4 becomes 2. like here I can, if I write, so it becomes 2 and it becomes 4, correct? So swapping will not create a problem. So it's a fine. So so right now it seems fine. Okay, you understand right now what I say right now. So after that, let's do the rest of the calculation. So now j will again becomes increased. Will become j will becomes 2 and j comes at this place. If you check, it will become this place. J will come here. Only select j, not select 1. Yeah, j will come this time. So 0 2. Swapping means 0 2 and 2 0. Fine, let's swap 3 7. Right now, still there is no problem. Like it is swapped. See, now the problem arises. Now j will reset to 0, right? J will reset to 0 because my n is 3 cross 3 here, so j will reset to 0. I will become 1. See here, I am already swapped. But if I keep following this formula, I have already swapped. Should I swap it again? No, right? Like if I swap it again, if you see, if I swap it again, 2 becomes 4 and 4 will become 2. So again, it backs to the original array. It come back to the original array. I am not getting the transpose. I shouldn't swap. So I have to omit this I. I can start from where? I can start from directly from 5. Because if I swipe directly from 5, 5 weeks swapping 5 with itself and it will not create any problem. Isn't it? So I can start with 1. Okay. So next, now if I swap 6 and 8, it becomes 6, it becomes 8. Now from next row, actually, I shouldn't do it, but think of it as 4 cross 4. There is multiple values present here as well. Okay. Here as well, here as well, here as well. What will you think? Like I have to start from here. Next row. So what I am doing? I'm starting from here first. Then I'm starting from here. Then starting from here. So my jth value should start with the ith value. My ith value is this one, right? 0. My current ith value is this one. So ith value start. I have to start from first one. I have to start from the beginning. The second one I start from the 1. When I'm j start is starting from 1. When the ith value is 1. When I comes here from here to here, then my j should also start from 1 as well. So this is the thing. Like j becomes 1. Sorry, not 1. J becomes I. From this place it will start. So this is the code of the transpose. Like I have to do the normal iterates for each and every row, but I have to start the column from ith column, not from the first zeroth column. Okay, this is the transpose. Now let's see how this transpose helps in our case. Let's take the this image and let's see how the transpose helps. What happens if I take transpose? Paste. So this is the transpose. Assuming like we are doing transpose, so I am removing these things. If I can remove this. Okay, so transpose. If I do the transpose, what will be my final value? Like 5 will stay here. Now 1 will come at this place. 1. 9 will come this place. 9. 11 will come this place. 11. Okay. And this is how it should looks like same thing for other element 2 4 8 10, then 13 3 6 sorry 13 3 6 7, then 15 14 12 16. So is there any solution? What is the final outcome? The final outcome is this one. This is the final copy. This is my actual output. Final. This is my final. This is my final. And this is my transpose. So what I can see here? Like is there, can you see any pattern with this? Like after transpose 5 to 13 and this thing, is there any pattern? Mhm. See the pattern. Everything is reversed. Here, each and every row is reversed. So, what is that? How it is helping? Okay. So, so this is how it is. We can get our new array without creating any problem or without any doing any problem, like creating any extra space. I mean to say. So let's start the pseudocode. The pseudocode is simple like this one. Like simply like I have to find n equals to as earlier that my matrix or here I am saying grid, right? So grid of grid dot length. I have to find the length of it. Simple. Now what I have to do? I have to do the transpose operation like same what I did earlier. Like for I equals to 0, I less than n, then I plus plus. Okay. Then for j equals to 0. Now j will start with I. If you remember, I said that j less than n, j plus plus. And what I have to do, I have to reassign the value. Reassign the value means I have to just swap of my grid of ij and ji. Ij and grid of j and I. I have to just swap the values. Okay. If I swap it, it is done. After that, as I said, grid of ji. After that, told you what I have to after everything is done, I have to iterate last time and just reverse each and everything. Okay. So reverse in the sense like how it is stored in the array, or you can see it is stored in this way, right? First is 15, then 13, then 2, then 5. It is shown in the grid, right? This thing is shown in the grid, right? So it should be shown like this thing. This is how it should store in the array or matrix, or sorry, in list. So it is stored like this thing, right? 14, 3, 4, and 1. This is how it is stored. Simply for others, and how it ends. So at the end, I have to do what? I have to iterate. So last time, I have to iterate like for. So if you for my I equals to 0, for I equals to 0, then I less than 1, less than n, then I plus plus. Simply I have to do what? I have to just reverse the particular thing. So I have to reverse like grid of I have to reverse it. Again I am saying use your own language thing, like your language, whatever the reverse function is there, use that reverse function. This is my pseudocode. Simply I'm not taking any expresses, I'm not taking any extra thing. This is the pseudocode. So what is the time complexity? Like let's talk about the time complexity in this. I forgot to mention the conclusion in the above case. Here the time complexity. Creating the grid. Here for Python it takes n square time creating the grid. Okay. So even if I take a constant for taking one length. Okay. So it will like it for every element I'm running. So it is directly n square. So this is exactly n square for each and any item I am going iterating through. It is exactly n square. Here it is what is it is. It is also each and every item I am going. So each and every item I am visiting. So it is exactly n square. Okay. So it is actually if I didn't consider this one, so it will also take n square of time to create or allocate the space or something. So it is it is big of n square. Okay, 2n square, 3n square you can say, but big of n square. So you don't calculate that one. So here, right now let's see here what is the time complexity here. Here it is n square, but it is less than n square because fast item it is actually fast item it is n. Next item is n minus 1. Next item is n minus 2. See here, what we did earlier, transpose. Transpose means first item I'm iterating to entire row. Next item I'm iterating this thing. Then it is this thing. Then it is this thing. Okay. So at the end it is n plus 1, n minus n plus n minus 2, then dot 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 plus 1. At the end it will be only one item. What is this? This is nothing but n into n minus 1 by 2. It's a formula. Fast sum of fast n natural numbers. So what is the time complexity here? It is actually big of n square. So it is less than actually n less than n square, but this is much slightly better than previous one. Okay. Okay, n square big of n square. So I'm considering n square. And what is this time complexity? It is an n cross n matrix. Like this loop will run for n times, and this one will run for how many times? It will run for what should I say? It is run for n log n time. In log n. This is the least time complexity it needs to sort an array in log n. So it is n square log n. Okay, n square log n. My earlier approach is n square. Now my this approach is n square log n. Okay, log n. The thing is, you can say like n square is it seems like it is a small lesser time complexity of n square log n. In somewhere it is lesser. After some time it will change. Like if I plot the graph, this is my n square. N square log n will like this. It is also a parabolic graph. Okay, but the thing is, at this point, assume this is my graph. So this is the current position. Okay. So at this point, this n square log n takes that amount of time. Let's see what is the n square takes. It is taking this amount of time. Okay, so there is a difference actually. So it is not purely n square. I don't think it's a pure n square. There's 2 or 3 n square. Okay. So at the end, this approach is much better. This approach is much better. This n square log n is much better than previous approach. Okay. Now let's focus on another thing. This is the actual approach you have to follow. The thing is there is one trick like you don't notice usually, like whenever you like everyone say this thing, then only you notice. There is one small trick is as well also there. Time complexity will be same, will be the exactly same, but you can see it is a much neat code, like more clear code it looks like. See this one, let's copy this one first. Copy this one or copy everything. Let's copy this one first. Copy. This is the copy. Okay. So what if I was doing what I was doing earlier? I was doing earlier first I doing the transpose, then I am just reverse the array. What if I reverse the array first? Reverse the array first in the sense, as I told, it is stored as this way. Like this is the outer array. Inside it is stored like this, like 5, 1, 9, 11, and so on so forth. Right? If I want to reverse it, what it looks like. I'm just writing the initial item, so it will be easy to understand. So if I reverse it first, so if I reverse, so what will be the final outcome? Final outcome will look like this. This 5 will come at the end, right? Obviously, it's a reverse, right? So file will, this first row will come in 5, 1, 9, 11. Okay. Then here it comes with the 2, 2, 4, 8, 10. Then it will be the same, like what is the thing, it is be 13, 3, 6 and 7, and then it will be again the same, it will becomes 15, 14 and 12 and 16, right? This is the final like after reverse the outer array. So what if I do the transpose here? Right now I'm doing the transpose. Transpose means this place will be swapped. So which place, like this place will be swapped. Like this place will be swapped, this 12 2 will be swapped, whatever the transpose is. So if I do the transpose right now, let's transpose. So what will be my final outcome? The transpose will be like 15 will be 15, 14 and 13 will be swapped. Then what? Okay, let's reduce it. Okay, so 13, 14 and 13 will be swapped. So 13, 14 will be swapped. 3 will be that. So I'm just doing transpose. Right now you know how to do the transpose. So this is the thing I'm doing. Transpose, simply transpose. So then 13, 3, then 6, then 7, then what? 2, 4, 8, and 10, and 5, 1, 9, 11. Okay. So this is the transpose. Okay. So right now, see with now what is my final array should looks like. If you notice, we get our final array already. We get our final array. So this is my exact final array. What it should looks like. Now, what should be the code of it? It will be exactly same, but I have to do the transpose earlier. I have to do the transpose earlier. This I didn't copy. Sorry. I have to reverse it earlier. Reverse it earlier. So if I show this, you can understand. Okay. So I have to find the grid as usual. But before doing transpose, I have to just what I call I have to just reverse the matrix. Reverse the matrix. So I will not do directly this transpose. Instead, I will just reverse the matrix first, then I will do the transpose. So it will be looks like this. My grid, I have to reverse it. Okay, forgive me for my spelling mistake. So now analyze the time complexity. Now what? Let's see what we get. So this is normal time complexity big O of 1. This is big O of n. Now n log n. See this one. There is a use change. It's a n log n. And the n it is becomes big O of n square as I explained earlier. Big O of n square. So if you look carefully, my fast approach. Fast approach is nothing but big O of n square. Okay. This is my time complexity TC. Big O of n square. Uh, this is my overall time complexity. Here it is what? In the second approach. First one it is a big O of 1. Second one is this is n square. I told you this is n square. And third one it is n square n log n. N into n log n. So what is my time complexity here? Time complexity is first one is big of 1, then it is big of n square, then it is n square log n plus n square log n. Whichever it is better, it will take that one. This is my time complexity. So it is nearly big of n square or n square log n. But here, see here. Here it is n log n, big of n log n plus big of n square, right? So this is the time complexity here. Whatever is the maximum, we have to take it. Now, what is the advantage? Big of n log n plus n square. What is the advantage? As I told you earlier, it is from the mathematical function, it is n square, but it is less than n square. And we know like n log n is less than n square as well. So at the end, the time complexity is overall time complexity is less than actual big of n square. This is the final solution. And it is obviously less than, not less equals to, because it will never touch n square. Because we are not iterating each and every element. We are iterating diagonally, only like half of the array, half of the matrix. So it is overall usually less than n square. So this is the most optimal solution. I will upload the same code. I will show you the same code, and I will also upload the code in the GitHub. Let me give you the code, like show you the final code. So this is the final code, as you see, like normal finding the grid, same number length of the n. Then I am reverse the array, reverse the matrix. Then simply for each and every element, I am just swapping the elements. So this is the thing, same thing. So the thing is, I didn't show this code, like let you know I have to write the code, same thing. I guess you can write the code. I will upload the code in GitHub. I will also upload the exact same code in the GitHub as well. Okay. So earlier I did a small mistake here. So in this place it is not actually big of n log n, it is actually n square. So whatever I did the mistake here, it is like it is takes if the arrays of array looks like this, right? This is the way they store. So if we consider each of the inner array as a single element, so it will take n log n, because sorting takes n log n time at minimum. But the thing is, it is not a single element; it's an array. Compare this array, it will take n time. What I'm saying, like if it is 1 and then 2, so obviously I can see in the past element, I can see it is 1 and 2, so it will be obviously lexicographical shorter than second element, right? But the thing is, it is not like that. If the thing is, first one is 1 and second one is 3, so this thing, like if there is at the end we can see like second, we have to compare all 3 4 elements, and then at the end we can see that 3 is smaller than 4, so secondary is lexicographical smaller than first one. So in that case, it is takes n time to compare, and this n times to compare so single element, and with the same thing like log n time, n log n time in for that n time to compare a single array, and n log n time to sort the array. So all equal is n square log n. So it is not actually n log n. And another thing, like what I told you earlier, that thing that I shouldn't. Okay, let me fix the issue first. N square log n. This is also n square log n, not in log n. So both of the cases, like if you reverse it earlier or later, it will be the exactly same time complexity. That's all. And but the thing is, what I was talking about earlier, like earlier I used to show one creating extra space. Why I did show that problem? So that is because assume it is a not n cross n matrix, it's a m cross n matrix, like 5 3 1 2 or 1 2 3 4, right? So if I have to do the same thing with the final output, what should be the final outcome? Like 1 2 3 4, and final output will be 5 3 1 2. Just simple of that, like right rotate as usual, like okay, right rotate. Okay. So for this type of question, you have to create excess space. There is no other option. You have to create excess space. So right now you have two options. After creating extra space, you can do the matrix reverse and transpose that thing. Otherwise, you can directly do what is the that what is called that indexing kind of thing. Okay. So there are two options. So let me write for normal option, like what is the, let's say, find out the indexing formula here. 0 1 2 3 and 0 1. So 0 1 0 1 2 3. So 0 0 0 0 goes to which place? 1 0, right? Then 0 1 goes to which place? Goes to 0 1 goes to 1 1. Then 0 2, it goes to which place? It goes to to 1. Sorry, here it is 0 0 goes to 0 1, 0 1. Okay, then 0 3 goes to which place? It goes to 3 1. All right. Similarly, like same thing, like what I told you earlier. Similarly, like 1 0 goes to 0 0. Then 1 1 goes to 1 0. Then 1 2 goes to 2 0. Then 1 3 goes to 3 0. Right. So this is how it works. So what will be the end of my syntax of this thing? So for I have to go I equals to 0 to I less than in and I plus plus. Pseudocode will be this, and I have to find out this. And for j equals to 0, j less than in, and j plus plus, j plus plus. This is what we have to do. Right. Now what is my new element? New element will be new of, I don't know what is the new element, but I know what is my old element. Old of I minus j, ij. Okay. So again, let's see the observation. Observation we can see again the thing is it is same, that what is the ith value and jth value will be the exactly same. So the j becomes their I. So I put that I put I as a j. Okay. After that, what we could do? Like I need a n. Right? So it is right now not a 2 n to 2 cross 2 or n cross n matrix, n cross n matrix. So it is a 2 cross 4 matrix and it is a 4 cross 2 matrix. Remember it. Okay. So what will be the my value? 0 and 1. Okay. So it will be m equals to 2, n equals to 4. So it will be m. Okay, I also did here. It is m. So here it is simple m minus 1 minus I, or m minus I minus 1, both are same actually. So what will be the value of that? M minus I minus 1. That's all. So that's why I show that different approach actually. Another approach you can actually do the same thing, the transpose. So if you do the transpose 5 3 1 2 and 1 2 3 4, if you do the transpose it looks like 5 3 1 2 and again 1 2 3 4, correct. And after that again you have to reverse each and every row of this 2D array, like 1 5 2 3 1 3 4 2. This is your final output. So at the, so here in this case you have to build a new matrix. There is no other way. You have to do a 2D array and then only you can put that place. So here it is much easier, like you have to do the matrix reverse and then put it back. Instead of that you can directly use this formula, right? This formula is useful. So that's why I show this formula uh, earlier actually. It will be helpful in future problems if it is the same as this problem. Okay, I will upload this new this modified problem as well in this GitHub. Okay, thank you then. Bye bye. As always, just put me again, like if there are did any mistake, just let me know. I will also rectify the mistake and I will also learn. Thank you. Bye bye.